Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve 8th problem of dynamic programming study plan. Minimum path sum. Given a grid M and fill with non-negative integers, find the path from top left to the bottom right, which minimizes the sum of all numbers along its path. We have to choose a path such that the summation of numbers in a particular path is minimized. Note, you can move either down or right at any given point. If you're standing in a particular grid, you can either move into the next grid which is on the right or to move to the down grid. Okay, only two options you have. Let's given a grid, let's try to write a recurrence relation. Okay, let's say I'm standing at an index I comma j. Okay, so in order to get answer to reach from I comma j till all the way till the end, we have only two options, either to go from I comma j to I comma j plus 1, which is right, or I can go from I comma j to I plus 1 comma j, right, which is in the downward direction. So the answer will be 5 plus answer coming from this cell, which is the minimum sum to reach from this cell to the end, and minimum sum to reach from this cell to the end. So the summation of 5 plus minimum of these two values, which is the answer to reach from this cell and this cell to the end. Okay, that is what I've written. F of I comma j will tell minimum sum of all numbers along its path, where if you take the downward direction, we will be having grid of I plus I comma j plus f of I plus 1 j. If you take the rightward direction, that means we have to increment our j, and my overall answer will be minimum of those two cells answer plus grid of I comma j. Okay, now that we have written our recurrence relation, let's also write the base cases. Okay, if you are standing on the end cell, okay, bottom left cell, that means you have already reached there. Okay, the path will be, the answer will be 1, which is the value of the grid, right? Or else if you are reaching out of bound of the grid, right, let's say from here you have taken right, that means there is no way from this particular cell you can come back to the end cell. Okay, so whenever we reach out of bounds either in a row or in a column, we will basically return integer dot max value, indicating that there is no way I can go back to the bottom left corner. Okay, for any given problem statement, of dynamic programming, it's always very important to come up with a recurrence relation, okay, and the base cases. If this part is done, 90% of the solution is already done. Okay, all we have to do is to implement the function with the same use cases. Okay, so I've just defined a function called top down, where I'm just setting m and number of rows, number of columns, and the grade and dp array at a class level. And then I have written a utility function called minimum sum, which will take the starting value as an input. Okay, so the minimum sum will basically take an index I comma j, and it will identify the minimum sum of numbers along the path to reach the end. Okay, so initially I'm just defining the answer as maximum value. So as I mentioned, the moment we have reached the bottom left cell, that means we have to return simply the grid value. If you are going out of bounds, then we have to return a maximum value, indicating that answer is not possible. Now that the base cases were done, now we have two options, either to go down or to go right. So my answer will come from any one of this, so I am taking minimum value. If I am successfully able to reach from the cell which is on the right and the cell which is on the bottom, okay, then I will be adding my current grid value to the answer which we have got so far. Okay, now the overall answer will basically contain, answer variable will contain the minimum summation of numbers. Okay, now if you see, there are certain states which will be repeating in the recurrence. Okay, whenever you draw the tree diagram, you will notice that the certain states are actually repeating and overlapping. So what you can do is simply memorize all of them. Okay, so I've just defined a dpr of size m and n of type integer. If it is null, if it is not equal to null, that means the answer to a given particular state is already calculated and I will be returning it, or else I will be storing the state. Okay, even though if you submit this problem, okay, if you submit the top down approach also, all the test cases will be satisfied. Okay, and if you can see, it is a pretty efficient solution as well in terms of time complexity. Let's analyze the time complexity for the top down approach. For the top down approach, as you can see, we are populating all these states of m by n grid. Okay, m by n dp array. So the time complexity will be order of m into n, and the space complexity also m into n, because we are using this 2D dp array. Okay, so let's also try to implement in the bottom up approach. Okay, as I previously mentioned, you should practice both top down and bottom up approach when you are preparing for interviews. Okay, it's very very important. Okay, if you are thorough with both the approaches, then only the chances of you getting selected in interview are high. Okay, so in the bottom up approach, definitely the bottom up approach is far more better than the top down approach, because there is no space coming from the recursion stack. Okay, so it's important that you are implementing this solution properly in the interview. Okay, so as if you observe the top down approach, the states are getting filled from bottom most corner to the topmost corner. Okay, in this fashion, right? So let's try to implement in the same way. Okay, I have a grid of, I have m, which is of number of rows, and n is basically the number of columns. Again, I have implemented here with the O of n space complexity. You can also do it with O of n square time space complexity as well. Okay, I'm just showing you the optimal path. I am giving you homework to implement it in O of n square as well, because first you implement O of n square and then you can optimize it by seeing at the solution. Okay, but anyhow, I will tell you O of n solution straight away. If you see, I have a dp array which will basically tell me what is the states which are so far calculated for a given row. Okay, let's say I'm standing on this particular row, that means I should know the states of the next row, right? If I know answer to reach, I can go down or I can go right. In order to go down, right, I should know what is the answer to reach from this particular cell to all the way till then. I should also know answer to reach from this particular cell to all the way till then. Let's say I am processing the last row. Okay, in the last row, I can only go in the rightward direction. Okay, so my answer to a given cell, okay, answer to my given cell will always be coming from its right side. Okay, so the current grid value plus the answer coming from the right cell. Okay, if I'm standing on the last cell itself, then my dp of j, the answer coming from this particular column to reach the end, is basically the same value. Okay, now if I'm standing in a column which is not equal to n minus 1, that means I am in these cells, my answer will be coming from its right cell only. Okay, the moment we have processed all these cells, now we will be knowing that the minimum sum required to start from all those cells to the end. Okay, now we'll go to the previous cell, one cell up. Okay, as you can see, I is going from m minus 1 all the way till the 0. Now m minus 1 is processed. Now we'll go to the one row which is higher than it. Now in order to reach, whenever you have in the last column, the only way is to reach the end is in the downward direction. That means I can only get it from its downward cell, right? So which is basically coming from the previous states of j, I mean the same j. Okay, so whenever I am in the last column, the answer will be coming from the dp of j, which is in the same in column. Okay, If I'm not in this particular column, then I can go towards right or I can go towards down. The down state is present in dp of j as I mentioned, okay, but the right state is present in dp of I plus 1, okay. So the overall dp of I comma j will be the grid of ij plus this particular value. As you can see, j is going from n minus 1 till j minus 1, okay. So my overall answer will be present in dp of 0. If you submit this problem, let me just have it in the over here. I'm just calling this particular function. This will definitely improve this memory, okay. As you can see, previously it was around beating 90%, now it was beating around 83% of the people, okay. So this approach is also pretty efficient in terms of space complexity. Time complexity will remain same because we have to process all m by n grid cells, so the space time complexity will remain as it is. The overall time complexity will still remain order of n square, but the space complexity is order of n using this optimal approach, okay. Don't miss to write the order of n square space solution as well, because you already know the recurrence relation. You just need to repeat the same process in the bottom up approach, okay. That's all about this video. Hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. Thank you.